So in x to the third, what does that mean? It really just means repeated multiplication. So x to the third means x times x times x. It's just kind of a shortcut way of writing that. So x to the 4 times x squared means x times x times x times x, 4 of them, times 2 more. This is what it means. This is a shortcut way of writing repeated multiplication. That's what powers are. So how many x's do we have? 1, 2, 3, 4, 5, 6 of them. So the reason why when you multiply like bases, we add the exponents is because of this. X to the 4th means the product of 4 x's. X squared means the product of 2 x's. So 4 plus 2 is 6. So when you multiply like bases, that should say bases, you add the exponents. So whether those like bases are variables or whether those like bases are numeric, the same rule applies. So here we have 2 to the 3rd times 2 to the 4th. We have like bases. So we could rewrite this as 2 to what power? 2 to the 7th. Now that we can actually simplify. 2 to the 7th is 2, 4, 8, 16, 32, 64, 128. We could simplify that to 128. Now here we have variables, and they're the same base, n to the 5th times n to the 11th. So when we multiply like bases, we add those exponents. 5 and 11 more make how many n's? 16. Okay, so we have a problem that has multiple variables. We're just going to look at one at a time. This is x to what understood power?
1.
The first, that's right. It's x to the first. Times x squared makes x to the 3rd. And then we have y to the 4th times y cubed is y to the 7th. So that's our answer. Our answer is x cubed y to the 7th. All right, I hear lots of sniffles, so I have words of advice. Make sure you're drinking a lot of water right now, you're getting plenty of sleep, and you wash your hands a bunch. Don't touch your eyes or your mouth. My husband and my son are at home today with over 100-degree temps. And they are headed to urgent care to see if they have the flu.
That was my family before Christmas.
Was it? Oh, I'm so not excited. So, I'm going home to disinfect my entire house today. Yeah, every doorknob, every faucet, anything anybody has touched will be. All right. Now this one, we have the coefficients and we have variables. Yes, sir. Okay. So 3 and 2. We'll deal with that first. Numbers are just numbers, guys. 3 times 2 is 6. All right. Now we have a squared and a to the 4th. So what does that make?
6.
A to the 6th. Then we have b and b squared.
B
B to the 3rd. And finally, c cubed times c is c to the 4th. Okay, so that is our first property. When you multiply like bases, you add the exponents. All right, so let's move on to division. First of all, let's talk about what's really happening, and then let's talk about what we do, kind of like a shortcut. So we know that powers just mean repeated multiplication. So if we had an example like this, x to the 5th over x squared. What is really going on? Well, we have the product of 5 x's in the numerator. That's what's really happening. And in the denominator, we have 2 of them. So when we go to simplify this, as long as we have everything written as multiplication, we just studied this with our rational unit. We know we can cancel anything in a numerator with anything in a denominator. So this x can cancel with that one. This x can cancel with that one. So all we're left with is 1, 2, 3 x's in the numerator. So that's what's really happening. But if we did that every time and wrote it all out, that would be a pain, and y'all would all quit school. So we're not going to do that. We're going to do the shortcut. So what happens when we divide like bases? What you're doing is you're subtracting the exponents. And I actually like to think of it, instead of subtraction, I think of it as canceling. Okay, so in this first example, we have n to the 13th over n to the 5th. So let's do subtraction. What is 13 minus 5? 8. Well, canceling is the same thing. So what I say when I do canceling is I say, okay, 5 of these cancel with 5 of those and leave 8. Okay, so we can think of it as subtraction or as canceling. If we subtracted, what is 2 minus 1? 1. What is 5 minus 3? 2. Or my favorite method, 1 of these cancels with 1 of those. 3 of those cancels with 3 of those. Oh, guys, this should be an 8 right here. There we go. Now, the reason I like the canceling method is when we subtract these, 2 minus 8 is negative 6. So that leads us to negative exponents. But if we think of this as just canceling, we say 2 of these cancels with 2 of those and leaves 6. But where did it leave them? In the numerator or the denominator? Denominator. So we know that x to the 6 is in the denominator. So what has to be in the numerator?
1.
A 1. Okay. So when we multiply like bases, we add the exponents. When we divide like bases, we subtract the exponents. Or you can think of it as canceling. So now we're going to look at our next property. What happens when we raise a power to a power? So this first one is, what does it mean? Okay, what does it mean when I raise a power to a power? See, what this means is I have 3 of the x squares that are multiplied times each other. X squared times x squared times x squared. And that makes 2, 4, 6 of them. Okay, so what would our shortcut be? Our shortcut is when we raise a power to a power, you multiply the exponents. So this is understood to be 2 to the first power. X squared y to the first power, z to the 4th. So if it doesn't have a power there, it's understood to be to the first power. Now each one of these powers has to be multiplied by 3. So what it becomes is 2 to the 3rd. And then x to what power? The 6th. we're multiplying. And then y to what power? That's right, the third. And then z to the 12th. Very good. Now, we can actually simplify 2 to the third. What is 2 to the third? 8. So this simplifies to 8x to the 6th, y to the third, z to the 12th. Z to the 12th. All right, only one slide left. Do you guys watch that as I teach? So you know how much is left? No? Okay.
No, I didn't know.
All right. So we have 2 properties left to talk about, and that's what happens with negative exponents and what is the 0 power property. Okay, so negative exponents. We would never leave our answer with negative exponents in it. So what do we do with negative exponents? They move. So a negative exponent means reciprocal. So if this is x to the negative second, it means the reciprocal of that, 1 over x squared. So if we have an entire expression raised to a negative exponent, we need to do the reciprocal of that entire expression. So sometimes you see it where the entire expression is raised to the negative. So you do a reciprocal. An entire expression is raised to a negative power. So you would do the reciprocal. So in the second one, what would happen is the first thing we do is flip this entire fraction. The reciprocal of 4a over b squared is b squared over 4a. And now it's to the positive second power. And that's the way we eliminate a negative exponent. Negative exponent just tells us to do the reciprocal. So now we have to square everything. B squared squared is what? B to the 4th. Okay? 4 squared is 16. And then a squared. Okay, but I want you to notice the difference between the second example and the third example. On the second example, the entire expression was raised to a negative power. So everything flipped. In the next one, the entire expression is not, just parts of it. B is raised to a negative power. C is raised to a negative power. But the 3 and the A are not. So what we do in that case is just the parts of the term that are raised to the negative power move. So this B is going to move to the denominator. And the C is going to move to the numerator. So the 3 and the a squared stay because they were raised to positive exponents. But the C had to move up and the B has to move down. All right, and the last thing I want to talk about is the zero power property, which says that anytime we have a non-zero number raised to a zero power, it is 1. It simplifies to 1. So 3 to the 0 is 1. Negative 50 to the 0 is 1. 4a squared b to the 0 is 1. Anytime we have a non-zero. 0 to the 0 power is, there's a special word for it, but it's not something that we have to find. It's indeterminate. Okay, any questions about that? All right, that's it. Did you remember most of those properties? Or was that, did it feel sort of new? No? Okay, well then I'm glad we did it. All right, I'm going to end the recording now.